So I'm going to talk to you guys about how to find average rate of change. But average rate of change is just another word for slope in relation to exponential functions. And the reason is because if I want to find the slope between these 2 points here, and I can't draw a straight line, but between those 2 points right there, that slope is different than the slope between these two lines, as it is but different between these two lines. It's just different with exponential functions between any points. So what we do with exponential functions is we find what's called the average rate of change. And I like to think of it as if I am driving from my house to the mall and my average speed is 45 miles an hour, that doesn't mean I'm going 45 miles an hour the entire time I'm driving to the mall. Sometimes I'm not moving at all. Sometimes I may be going 60 miles an hour. Sometimes I may be going 30 miles an hour. So that 45 miles per hour would just be the average speed that I drove over the entire trip. So that's what happens here with exponential functions. You're just finding an average rate of change. Now, what's going to also happen with average rate of change is you are going to have to be given an interval, because if I just asked you to find the rate of change and I didn't tell you what interval, you could have a different rate of change than I would have. So you're always going to be given an interval, and that interval is written in interval notation, and there's brackets around it. So I'm going to use -1 to 1. So this means we're using the interval from when x is -1 to when x is 1. So we're going to find the rate of change on this part right here of the exponential function. So that means I'm going to use x when it is -1, and I'm going to use, that was a bad circle, I'm going to use x when it's -1, and I'm going to use x when it is 1. X when it's -1, and x when it is 1. And I'm going to plug it into the slope formula. And it's the same slope formula we used back with linear functions. And that is y2 minus y1 over x2 minus x1. And again, it doesn't matter which one's your first point, which one's your second. It doesn't really matter. But the basic difference is you have difference of your y's over over difference of your x's. Okay? So I am just going to say that this is x1, y1, and then I'm going to say that this is x2, y2. If you have yours flipped, it's okay. It's not going to make a difference because the answer will be the exact same in the end. So I'm going to plug it in. So y2 is 2 minus y1, which is 8, over x2, which is 1, minus x1, which is -1. 2 minus 8 is -6. 1 minus -1 is 2. -6 over 2 is -3. So the average rate of change right here is 3. All right, let's do another one. We're going to use this function, 4 times 2 to the power of x. And so as you can see, it's a growth equation. And I'm going to find the average rate of change over the interval of 0 to 2, meaning when x is 0 to when x is 2. So we're going to find the average rate of change over this interval right here. So we're going to use these 2 points right here when x is 0 and when x is 2. That's what that interval notation means. And I am going to say that this is x1, y1, and that this is x2, y2. And again, the formula we're going to use is y2 minus y1 over x2 minus x1. And so when I solve it, y2 is 16 minus y1, which is 4, over x2, which is 2, minus x1, which is 0. 16 minus 4 is 12. 2 minus 0 is 2, and 12 over 2 simplifies to 6. So the average rate of change here is 6. Now, these examples that I've given you, neither one of them ended up being fractions, but they can be fractions, and that's okay. That doesn't mean that you've done anything wrong, okay? There's nothing wrong with fractions.